Hello everyone, welcome to Integrated Math 2. We're talking about 4.2 Pythagorean Theorem. So let's write that in. Make sure you put your first and last name and your period number. And we are discussing 4.2, the Pythagorean Theorem. But also its converse. So here is our theorem. In a right triangle, that looks like this. Here's a right triangle. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if this is A, and this is B, and this is C, then A times A plus B times B is equal to C times C, or A squared plus B squared is equal to C squared. Now, when we're getting to squares and stuff, you're going to want to make sure you use your handy-dandy calculator, or else you're not going to have a good time. All right, guys, let's continue on. Now, there are going to be some cool numbers that are going to be nice and easy. These are called Pythagorean triples. Just like perfect squares, they're going to be nice 3 whole numbers that can be solved relatively easy when we're dealing with right triangles. Here are just a few for you to remember later. So we have 3, 4, 5. So the largest side will always be the hypotenuse. This is the side that is across from the right angle. So this would look like, for this one, just right here, that would look like 3, 4, and 5. So I'm going to write out what it would look like. 3 squared is 9, 4 squared is 16, is equal to 5 squared is 25. Now I'm not going to do it on every single one, but if we add these together, we would definitely get 25 is equal to 25. The next one, 5, 12, 13, 25 plus 144 is equal to 169. Next up, 8 squared is 64, and this is where Mr. Schultz has to pull out the calculator. 15 squared, 225. So if I got out my calculator and I did 17 squared, I should get 289. There's no way I should know that, but let's put 17 squared and check. Yep, 289. Now this next one, 7 times 7 is 49. And then I'm not going to expect you guys to know this, but 24 squared is 576. And then 25 squared is 625. So these are all perfect examples of Pythagorean triples that are nice, easy to remember. At least the first 2 right here are nice, easy to remember. The last 2 right here, I don't remember, so I don't expect you to remember as well. But you don't need to know these. This is just a trick for you to understand for later. For example, we can solve right triangle problems, finding the distances of sides using the Pythagorean theorem. So it says find the value of x. So we have a side 3, and the hypotenuse of x. So I know for this one, it'd be 3 squared plus 3 squared is equal to x squared. All right, well, just solve it. So we have to resolve each step in this. Keep going until the very end, until we get x by itself. And this is the last step, and this is one of those new ones right here. We have to find to get rid of squaring, we're going to find the square root. And so that's going to cancel out. The right side right here is going to cancel out. But this 18, the square root of 18, that's not going to be so nice. All right, so this square root and the square cancel out. So I'm left with x. But on the right side, I can break this up over here. I know the square root of 18 is 9 times 2. So the square root of 9 is 3. So this would be 3 radical 2. I'm going to put this in right now. So the answer to x is 3 radical 2. All right, guys, let's continue. All right, so question 2, it's part of your homework. Here's the setup. Remember that it doesn't matter, we're not putting x by itself. We're creating an equation and then getting x by itself. So in this first problem, the only reason why x was by almost itself right here was because that was the hypotenuse. A squared plus b squared is equal to c squared. For this one, we have a squared being 9, b squared being x, and c squared being 15. So you're going to build the equation and then solve for it. So if you do that, you'll get the answer of x is equal to 12. So go ahead and work out that problem, and then we're going to go on. All right. So now we're going to do these next two problems. I'm going to give you the answers, and I want you to show the work. All right, so the answers I got was x is 1/3, and x is the square root of 1345. So you can see on one of them, the square root, it's a perfect square and it goes away. On the other one, it doesn't. So in your work, don't get too frustrated if it doesn't go away for number 5. All right, let's do the next example. Example 3, construction. The bottom end of a ramp at a warehouse is 10 feet from the base of the main dock, and the ramp is 11 feet long. How high is the dock? All right, well, these problems are just literally real-world problems. So let's do it. Now, understanding that this is a right triangle right here is imperative. If they didn't actually give us this diagram, we'd want to draw it ourselves. So right now I know this is going to be 10 squared. Well, I know it's going to be feet, but this is going to be feet. Like every one of these is going to be feet, but let's not talk about that. 10 squared plus, let's call it height, h. 10 squared plus h squared is equal to 11 squared. So that's 100 plus h squared is equal to 121. So I could subtract by 100 on both sides, and I'll get 21 is equal to h squared. So now all I have to do is I have to find the square root. So I find the square root of h squared, which would be h, and I find the square root of 21, which would be 7 times 3. Oh, it's just 21. So what I'm going to have to do is, if this is a real-world problem, I should actually find out what is the answer. And it's 4.58. So 1 second though, we go back and we see this, and we need to write down the actual answer. Whoop, typing it out. The height of the dock is 4.58 feet tall. There you go. So when you're doing these problems, you have to change your answer in the course of, what makes more sense. And in this case, if we're building a ramp, we kind of want to know the actual amount. So here we go. I want you to do number 7. I'm going to give the answer in 3, 2, when. Alright guys, so doing the work we get a perfect number back out and we get 65 miles. So this is one of those Pythagorean triples where it gives us a nice number back. So if this is 25 miles, this is 60 miles, then this is 65 miles. But wait, we're missing two things for this problem. One, we're missing our work. And two, we're missing a sentence. So how far apart are the two airports? The two airports are blank miles apart. All right, let's continue. We are almost done with this work. We have 4 pages and we are at the end of page 2. Let's go on. So the converse. So if it's a right triangle, Pythagorean theorem is, if it's a right triangle, then the sum of the squares of the legs is equal to the sum, or the hypotenuse squared. Basically, if it's a right triangle, this is true. So this is going to be a right triangle. Remember, it looks like the following. It's a right triangle, and we have A, and we have B, and we have C. Now there is a converse. If the sum of the squares of the lengths of the shortest sides is equal to the square of the length of the longest side, then it's a right triangle. That's all the converse is. Instead of saying, hey, if it's a triangle, right triangle, then a squared plus b squared equals c squared. Now it's saying, hey, if a squared plus b squared is equal to c squared, then what type of triangle is it? It's a right triangle. All right, so now they give us this idea right here. If the longest side is less than the sum of the two sides squared, then this is going to be an acute angle. And so this would be kind of look like this, and we can call this C, A, and B. So it's not going to be like these two are going to this squared plus a squared plus b squared would definitely be bigger than c squared. And so this right here would be an acute triangle. Now, if it's larger, so it looks kind of like this is bigger than a 90-degree angle, well, then it is obtuse. Go ahead and write that in. Obtuse. It's an obtuse triangle. So in this, if the two sides squared are less than the hypotenuse squared, it's not the hypotenuse, but the longest side, then it's obtuse. It can't be the hypotenuse unless it's a right triangle. All right, so that's our converse with the added fact of, hey, if it's acute, obtuse, or right, there's something there. If it's equal, if c squared is equal, c squared is less than, or c squared is greater than. All right, last part of this. Example 4, classifying triangles. Or what I like to think about is using the distance formula to determine if it's a right triangle or not. So what you have to kind of do is you have to figure out, all right, I need to find between x and y. What's the distance between x and y? What's the distance between y and z? And what's the distance between x and z? So we have to use our distance formula. If you need to look it up, go ahead, but I'm going to write it. Why don't we write the distance formula right here, just so that you remember it. Go ahead and Google it right now. Let's see if you remember it. In 3, 2, 1. All right, so there's our distance formula. And wait a second here. We have the x value squared plus the y value squared, and then the square root. That looks like the Pythagorean theorem. Pretty much. That's our distance formula right there. So we're going to figure this out using these numbers. So if we're doing x to y, we're going to take our x values and go, all right, -3 minus -1 minus minus plus plus. And we're going to add them to, after we square them, to the y value, which would be -2 and then minus 0 squared. So let's see if I can get this. So -3 plus 1 is -2 squared plus -2 squared is going to be 4 plus 4, which is 8. So this is radical 8. Cool. Now let's see if I can do y to z right here. Y to z. So y to z would be -1 minus 0 squared plus 0 to -1, which, is not going to do anything. It becomes a positive 1. So this will be 1 plus 1, or radical 2, is equal to yz. All right, last one, x to z. So we're going to find x to z is equal to the radical, or the square root, of -3 minus 0 squared plus -2 minus minus 1 squared. So minus minus becomes plus plus, and so we get -3 squared plus -1 squared. And we have to find the square root of x, z. So -3 squared is 9, -1 squared is 10. And so we got -2. So here's a problem here. We have -2 plus -8 is equal to -10. But is it? We're going to put a little question mark right there. Let's do a different color. Is that true? Let's take a poll in class. Mr. Schultz is going to ask, what do you think? Is this true or not? Let's take a poll in 3, 2, 1. All right, so now let's use our calculators and see if it is true. Okay, so using our calculator, we get this. And we're like, all right, will that work? And it does. But wait, watch this. Now the trick for this one is, if we square them, this should equal to each other. It's not this, it's squaring. So it's the square root, or the squaring of this, plus the squaring of 8 is equal to the squaring of 10. So if we, or the square root, squaring the square root of that. So we get 2 plus 8 equals 10. Because remember, we're not adding these together. That's not what we're going for. What we are going for is for the squaring. Because remember, it's the Pythagorean Theorem with a squared plus b squared is equal to c squared. Now the trick is not the sides added together is equal to the third side. It's the sum of the squares of the sides. So I threw a little trick at you right there. All right. Now, if you actually look at the rest of the problems are going to be your homework. So go ahead and work as hard as you can with your group or with a partner. And you guys have a wonderful day. Bye, everybody.